quickly begin. All right, welcome to today's tutorial. So today we're just having a tutorial. In other words, we're just going to go through questions. That is the activity in your handout. Okay. So let's begin. Okay, so in your activity, there are these questions which some of them I gave you as an exercise, and I was happy to see that most of you did well in some of the questions, though some of you failed to understand certain questions. And it's good that we've repeated the same questions in the tutorial, so that if you had a question or if you didn't understand somewhere, you have at least time to ask. All right, so let us quickly begin. So the first question is, if A is 2, 3, 4, 5, B is equal to 2, 4, 6, 8, and then C is equal to 3, 4, 5, 6, and the universal set is from 0 to 10. Find A intersection B. So I believe A intersection B is not something that most of you can fail. A intersection B. So A intersection B is simply just A intersection B is simply just finding common elements between A and B. So when you look at A, in A we have 2, in B we also have 2. So 2 is common, you can write 2. We have 3, we don't have 3. We have 4, we have 4 there. So you can also write 4. Then we have 5, we don't have 5 in B. So we can leave them like that. So A intersection B is simply just that. So this is part A. Let us also quickly look at part B. I don't know if you have questions about the intersection. Okay, so let us look at part B, which is part 2 of A. Okay, so this one is A intersection B complement. So A intersection B complement was simply listing the elements that are not in the intersection, but they are present in the union set. So which are these elements? So these elements are simply just, we know that the universal set is starting from 0 to 10, and then the intersection is simply just 2 and 4, meaning we're going to list numbers starting from 0. We have 0, 1, 2. Oh, sorry, 2 is part of the intersection, so we're not supposed to add 2. So we just say 0, 1, 3, and then 4 is in the intersection, but we're looking for the complement, meaning we'll not write 4 as well. So 3, we move on to 5, and then we have 6, 7, 8, 9, and 10. Okay, so let us find the third part here, which is A union B complement. So to find A union B complement, we first have to know what A union B is. So A union B complement, I'll write the answer here. So first of all, let us find what A union B is. So A union B is simply just a combination of A and B. We combine A and B, but to make sure that if one number is repeating itself, if it's in both A and B, we just write it once. So we have 2, we have 3, 4, 5. Then this side in B we have 2, 4, 6, 8. So we have 2, 3, 4, 5. Then we have 6, and then 8. So this is our A union B. Now to find the complement of this set, we simply have to list the elements that are in the universal set, but they are not in, the elements that are in the universal set, but not present in A union B. Which elements are these? This is 0. We have 1, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. So we don't have 7 there. 7 is not there, 8 is there, 9, we don't have 9. And then we also don't have 10. So this is A union B complement. So we move on to this part. So this part first have to be simplified. We can simplify it before we start solving it. So part 4, this is A intersection B minus C. But we know that B minus C is simply just B intersection C complement. So B intersection C complement, we can first start by finding this sum part, and then we find the intersection with the answer that we find with, between the answer that we find and F. So to find A intersection C B intersection C complement, first C complement is just numbers that are not in C. We have 3, 4, 5, 6. So we list C complement. When we list C complement is simply just numbers that are in the universal set but not in C, which are we have 0, 1, 2, and then we have 7, 8, 9, 10. So this is our C complement. So we intersect it with B. So B, oh, sorry, not B complement. Yeah, so B is simply just, oh, sorry. Okay. So B is simply just, let me just copy it here, 2, 4, 6, 8. So this is B. So find the intersection between these two sets. So the common elements between these two sets are, we have 2 there. We have 6 is not there. We have 8 there. So this is what we have as B intersection C complement. And then apart from that, let us now intersect this with A. Intersect A and the answer that we have found. The answer that we have found is simply just 2, 8. So we find the common elements between A and 2, 8. So let me put A here. A is simply just 2, 3. There's a question. Network is very bad. I guess maybe it's just in your area. Yeah, I guess it's in your area, because if the network is very bad where I am, Zoom is able to tell me that my network is bad. Yeah, so I'm sure it's just in your area. I'm recording the session, so don't worry, I'm going to send the session in the group after this. So we have A is equal to 2, 3, and then we have 4. We have 5. So this is our A. So let us find the intersection between A and this set here, which I guess everyone can see to just simply be 2, because 2 is the one that is just common. We have 2 there, we have 2 there. So this is the answer. So we have 2 there. So the answer is just 2. So let us quickly move on to this one here. So this one is X. I'm sure, let me just erase the top part so that we can use it. Okay. Okay. I think I'll erase up to this point to help those who are copying to copy what is down. Okay. All right, so let us find this one. So we have X minus, so X minus C is simply just the same as X intersection C complement. Then there's a complement outside, which is there. Then we have intersection here. Then we have A minus B, which is just the same as A intersection B complement. Yeah, so that is what we have. And then from there, let us now quickly find, yeah, so we can now quickly find this part here, X intersection C complement. Remember what we said, the universal set, if you remember the rules of sets, there's a part which I mentioned saying the universal set intersection any set is just the same set. So here we have X as our universal set. So X intersection C complement will just give us C complement. And then there's a complement outside C. So you look at that, this complement can also cancel with that. So meaning we have, yeah. So we just have C intersection, and then A intersection B complement. Oh, sorry, the complement is supposed to be inside, not outside. So even there, the complement is supposed to be there. Okay. So let us now find the other part, which is remaining, which is just C. I mean, C we already have, which is there. Then let us now just find A intersection B complement. So our A is simply just there. And then let us find B complement. And I guess if you find B complement, it means that we've also found the last part here, which is just B complement. Okay. So B complement is simply just going to be elements that are in the universal set, but not in B. Which elements are those? We have 2, 4, 6, 8 in B. So B complement will simply just be 0, 1, 2 is in B, so we don't write it. Say 3, 4, 6, 8, 9. Then we have 10. This is our B complement. So we intersect this with A. We find the common elements between A and B complement. So, so let's say C intersection. Let's write our set here. The answer is side. So the common elements between the common element
on B complement.
Okay.
So have 6 in the list which
sorry,
you have written.
Thank you very much. Thank you very much for that correction. So 6 is not supposed to be part of this set. Okay, because it's in B. So in B complement, it's not supposed to be there. So let us list the common elements between A and B complement. So A and B complement, the common elements are simply just, we have 3. 3 is common. I think that's the only number which is common here. That's the only element. Yeah, we only have 3. So you can write it there. Then we intersect C and 3 again. We see if we have 3 in C. Yeah, so C intersection 3 or C intersection A intersection B complement will just give us 3 because 3 is common in this set and in set C. So we have 3 in set C as well. So 3 is common. And hence X minus C complement intersection A minus B, intersection A minus B, the answer is just 3. Yeah, so for the last part, which is just B complement, is just exactly what we found here. So let's move on to the next question. I don't know if you people have a question here before I proceed. Okay, so let's move on. So here, this is question 1B. Using the same sets above, confirm that confirm the associative or the associate law. Sorry. Yeah. So what they are trying to tell us is that we confirm that this part is equal to the other part. So I'm sure this is straightforward. Maybe I just go to Demogan'S because what they want you to find here is just, for instance, you just start with A intersection B and then intersection C. So you find this one, you say your left-hand side is equal to this, then you also find your right-hand side. So your right-hand side is just this part, which is A intersection B intersection C. Yeah, so you first have to find this part. First you find A intersection B, and then you find you intersect it with C. You find your answer here. When you find your answer there, you also find the right-hand side, which is A. You start with what is in the brackets, of course, and then after dealing with B intersection C, you come and intersect it with A. You also find the answer there. Yeah, so you just have to compare these answers in case they are saying confirm. So the question, when the question is saying confirm, it means that they know to say this part is equal to that part. So meaning the answer that you find here is automatically supposed to be the exact answer that you're going to find on the other side. Yeah, so if you find different answers, just know that you've made a mistake somewhere. All right, so same applies to distributive law here. So distributive law, you also have to do the same. You also have to do the same. Let me just illustrate it here, how to solve it. So the distributive law, you also have to do the same. This one here. So you get your left-hand side, which is just this part, which is A union B intersection C. You find the answer for the left-hand side. You find the answer here. Of course, you should always be starting with what is in the brackets. You follow BODMAS. BODMAS is simply just brackets of division, multiplication, addition, and subtraction. So you start with what is in the brackets first. You deal with them. Then you come and combine it with what is outside. Then from there, you also get your right-hand side. The right-hand side will simply just be A union B in brackets, and then intersection A union C. So you first start with what is here and there, you find them. You find this alone and that alone, and then you come and find the intersection set, the intersection between this and that. Yeah, so when you find your right-hand side, this one should also give you the same answer as the left-hand side. Whatever you find here should be exact as what you're going to find there. Yeah, so that is exactly what you're supposed to find. Yeah. Yeah, so that's what you do. Let's quickly move on to the next question, which is Demogan'S. Okay. So Demogan'S is straightforward. So let's move on to Demogan'S. All right, let me just mute everyone. Okay, so Demogan'S law is simply just this one. Some people call it a complement law. This one. So the way it is that when you open the brackets, you distribute the complement, the sign in between has to change. So when you distribute the complement there, the sign there, if it's union, like for instance, the way it is there, it will become intersection, and then B complement. So you first deal with this. So how do you deal with this left-hand side? So the left-hand side, you first deal with what is in the brackets, you find the answer, and then after finding the answer, you find the complement of that answer, given the universal set. We've been given the universal set in this question, because they are telling us to say, we use the same sets which we have here. So we use the same sets, which have been given, these sets A, B, and C. We use these same sets, even the universal set there. Okay. So maybe let me solve this one instead of just leaving everything without solving. So we have A, which is equal to, so A is equal to 2, 3, 4, 5, and 2, 3, 4, 5. Yeah, so A is equal to 2, 3, 4, 5, and our B is simply equal to 2, 4, 6, 8. And then C, let me erase this first. And then C is 3, 4, 5, 6. So C is simply just 3, 4, 5, 6. So that is our C. So from there, we can now Yeah, so from there we can now prove our Demogan's law. Oh, the universal set. So the universal set X is simply just numbers from 1 to 10. So from there, let us find A union B. I mean, let us prove the first law there, which is A union B, then complement outside is equal to A complement intersection B complement there. So when we take the left-hand side, which is A union B complement, let us first find A union B. So A union B, so A union B will simply just be equal to the combination of A and B, which is just 2, 3, 4, 5, 6, 8. So this will be 2, 3, 4, 5, 6. We don't have 7, and then we have 8 there. So after that, we find the complement of this. So the complement of this set, given the universal set from 0 to 10, is simply just going to be, so the complement of this set will be our answer there, which is just 0, 1. We have 2, 3, 4, 5, 6, 8. So 0, 1, 7, and then 0, 1, 7, and 9. I mean 10 and 9 and 10. Yeah, so this is the left-hand side. Let us now find the right-hand side. Yeah, so the right-hand side is simply just A complement intersection B complement. Okay. So the right-hand side is simply just A complement intersection B complement. So we find the right-hand side, which is just A complement intersection B complement. So A complement intersection B complement. Let us first find A complement. We also find B complement, and then from there we find the intersection set between the two sets. Okay, so A complement will simply just be, we have 2, 3, 4, 5. So we list numbers in the universal set which are not present in A. So A complement is simply just 0, 1, 2. Oh, sorry, we have 2 there and 3, so we don't have to include 2. So we have 0, 1, then there's 2, 3, 4, 5. So we write 6, then we have 7, 8, 9, including 10. That is our A complement. Let's also find B complement. So B complement, in B we have 2, 4, 6, 8. So B complement will simply just be 0, 1, 3, 5, 7, 9. This is 9. Then we have 10. So now to find A complement intersection B complement, to find A complement intersection B complement, to find A complement intersection B complement, we simply just find the common elements between these two sets, here. Find the common elements. So we know to say, as we can see there, we have 0. 0 is common. We have 1. From 1, the other number which is common is we have 7. Then we have 9. Then we have 10 is also common. So this is the solution for A complement intersection B complement. Now you have to compare the two solutions. If they are different, it means that you've found you've done it in a wrong way. Your solution is wrong. Yeah, it means that you've gone wrong somewhere. So let us now check if these two solutions that we found are correct, or I mean if they are the same. Let's compare them. We have 0 there, we have 0 there, we have 1, we have 1, we have 7, we have 7, 9, 9, 10, 10. Therefore, we are confirming this. So you just say, therefore, the left-hand side is equal to the right-hand side. Hence, this confirms the Demogan'S law. Okay. All right. So I don't know if you have questions on this before we proceed. All right. So let's proceed. Okay. So this one here is the exact question that I gave you in the exercise. So on this one, I think I'll not solve all the questions. I'll just pick, anyway, we'll see, maybe we'll just solve everything. Yeah, okay. So we have A being equal to that. A is open at 2, closed at 4. B is closed on both ends. C is open on both ends. And the universal set has been given to be that. Find each of the following sets and display it on the number line. So C complement. So our C is simply just 4,7. That is our C. So meaning our C complement will just be numbers that are outside C but present in the universal set. So the numbers that are in the universal set but outside C, we have 0 outside the universal set, and then comma, we are ending at 4. 0,4, but since 4 is not part of C, it's going to be part of the universal set. Then we say union. 7 is not part of C, meaning it's going to be part of the universal set. Meaning it's going to be part of the universal set. Then we say comma. What else? Yeah, so it's going to be part of the universal set, and then we say comma, and then we write 10 there. Yeah, 10 is also part of the, sorry, not the universal set. I said 7 will be part of the complement set. Yeah. So this is the complement of C. So let us now draw the number line. So the number line, we have numbers from 0 to 10. 0, 1, 2, 3, 4. We have 5, we have 6, 7, 8, 9, and 10. So from there, we can put our set there, which is our C complement. So it's shaded at 0 and shaded at 4. Shaded at 0 and shaded at 4. And then from there, it's it's shaded at 0 and shaded at 4. Then from there, it's shaded also, it's closed at 7. It's closed at 7. It's also closed at 10. So this is how you write this is how you represent it on the number line. C complement, C complement. So I don't really know if there's a problem on this question. If you have problems, or if you have people with problems. Okay, let me just solve another 2 questions maybe. Then we proceed. Okay. All right. So these things are simple and straightforward. Okay, so let me pick another one. I'll pick this one, B minus C. So when you say B minus C, B minus C is simply just the same as B minus C is simply just the same as B intersection C complement. So C complement is what we've just found, which was 0 to 4, and union. This was our C complement, and then union 7 to 10. So this is our C complement. Now we intersect it with B. Find the intersection between C complement and B. We know that our B is simply just 3,7. It's given in the question, it's there. So we find the intersection between these 2 sets. How do we find that intersection? I told you that the simplest way to find the intersection is simply by just drawing a number line. Then you put in the numbers. So you have 0, 3, 4, 7, 10. So you have 0, we have 3, we have 4, then we have 7, we have 10. Then these numbers, let us now draw these numbers. So let us start first by drawing C complement. So C complement is just from 0 to 4. Now 0, it's closed at 0, it's also closed at 4. Then from there, it's also starting from 7. Oh, it's closed at 7, it's also closed at 10. So let us also, so this is C complement. Let us now draw the one for B. B is starting from 3 to 7. It's closed at 3. It's also closed at 7. So from there, you can find the common parts. So we know that the common parts where the lines are intersecting. So the only part that these two lines are intersecting, this is our B, is this part. But there's also this point where these two lines are intersecting. So what we do is, we're finding B minus C. So this will just be equal to, we write this part, this region where these two lines are intersecting. We have 3, 4 closed on both ends. Then we say union. Then this point, since this is just one number there, if it was a region, we would have written it in this format. But since it's just one number, you write it using these brackets. So this is simply what you were supposed to find. So this is how you find this question. So I believe the other questions you people can manage to find. So what you can do is that you can, as you are going through mathematics, maybe if you are going to have time, you go through this question, you can submit the remaining 3 questions. This one, and this one. You submit them on my WhatsApp line, and then I'll check through to see if you've gotten it correct. Because the main concept here that you just need to understand is the concept of, the part where you're just supposed to, where you're just supposed to draw the number line. So after finding this final answer, let us now draw the final number line. The final number line will now be like this. The final number line, we just put the answer on the number line. So we have numbers ranging from 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 10. So from there, let us put these numbers on the number line. We have from 3 to 4. So we have closed at 3, close at 4. Then we combine this. Then we also have a dot at 7. So this is our B minus C. B minus C. Yeah, so that is what you are supposed to find. Right. Do we have questions on this question before we proceed?
Yes, sir.
Okay.
Maybe, yeah, how do we present the same information if you find that your answer is an empty set? Now on the real line, how do you represent the information on a real line if your final answer is an empty set?
If the answer is an empty set. Oh,
yes.
Oh, that's a nice question. I've never seen an empty set on a number line. Okay, what I think for me, what you can just do is you just draw the number line without putting anything. I think so. You can just draw the number line without putting anything. Yeah, maybe what you can just okay, you don't even have to show the universal set, because when you show the universal set, simply means that you are telling the marker that the answer that you found was the universal set. So you just draw the number line, I think so. Just put in the numbers which are supposed to be there, and you leave it there. Okay. All right, do you have another question? All right, let's proceed. So we have this question also. So we're remaining with 3 minutes. In case it cuts, I'm going to send another link to the group and everyone should join. And everyone should join so that we proceed, we finish the whole activity. So question 3 is here, which says, if A is a subset of B, then simplify if possible. Okay, so what they mean is that if you have a set like this, then this is U, and then you have A and B in the set. We have A is a subset of B. So we have A inside there, and then we have B outside. Okay, so we have B outside and then A inside. So this is what they mean. Okay, someone is asking that how many questions do we have in total? I think we have 5. We're just remaining with 2, I think so. Yeah, we'll just have 5. So when we're done with this one, meaning we'll just remain with 2. Okay, so saying A is a subset of B, and then the first question there is find A intersection B. So if A is inside there, is inside B, meaning A intersection B will simply just be, all right, okay, so A intersection B, so A intersection B will simply just be A. So if A is a subset of B, A intersection B, the intersection meaning the common elements between A and B will simply just be A as the answer. Then from there, let's also look at this one. We have A, so we're looking at part 2. This was part 1. Okay, so part 2 is A complement union B complement. So A complement union B complement, according to Demogan'S, can be written as A intersection B, and then everything in brackets with a complement outside then. So I've just done the reverse way of Demogan'S law. So from there, we know that our A intersection B, this A intersection B is simply just A. So A intersection, A union B complement, A complement union B complement is simply just the same as, so A intersection B, we found it to be A, so we can just write our A there. Then this complement, we just write it there. That is our answer. Then on the other part, which is part 3. So part 3 is simply